Italy has many volcanoes, including Stromboli, an island volcano that has been active for much of the last 2000 years, therefore referred to as the lighthouse of the Mediterranean, and the Etna volcano on Sicily that has frequent eruptions and has also a continuous gas plume, a prime example of open system volcano that continuously emits volcanic gas towards the surface. We are going to have a look at volcanoes near the city of Naples. There we have the famous Vesuvius volcano that we can see here. In 79 AD, this volcano had an explosive eruption and pyroclastic flows that buried the towns of Pompeii and Herculaneum. A famous written description exists of the eruption by Pliny the Younger. Powerful explosive eruptions, Plinian eruptions, are named after him. Vesuvius is located next to Naples. This video is showing an overview over the downtown Naples area. Vesuvius had its most recent eruption during the Second World War. Since then, the metropolitan area has expanded tremendously onto the slopes of the volcano. The volcano has eruptive periods, a series of eruptions, but is quiet in between. But there is another volcano undergoing volcanic unrest at present, even closer to Naples. This is the Campi Flegrei caldera that partly lies underneath the Naples metropolitan area. If you want to go there, you can use the public train system of the city of Naples and make a stop at the Campi Flegrei train stop. Here at the train station we can see part of the caldera boundary. The hill in the background is the wall of a caldera. A large caldera-forming eruption occurred here 15,000 years ago. The most recent eruption within the Campi Flegrei caldera occurred in 1538, but the caldera is at present in the state of unrest. Here is a map showing the geological context. There have been more than one caldera-forming eruption. The caldera boundaries are indicated. The most recent eruptive site in 1538 is shown with a red arrow. Downtown Naples and its harbor area is indicated, underlined in red. Mount Vesuvius is just east of this map. The town Pozzuoli is in the center of the Campi Flegrei caldera. It is close to the center of unrest. Note that half of the caldera is below sea level. The presence of Roman ruins along the shore provide an unusual benchmark, which have recorded the ground displacement with respect to sea level during the last 2,000 years. The marble columns of the ancient Roman market in Pozzuoli, known as Serapeum, have fascinated generations of scientists. These pillars have been a key to understand the deformation. This graph from Todesco and colleagues shows the reconstructed vertical motion of the Roman columns of Serapeum. The x-axis is time, a total of 2,000 years. The columns were built above sea level, but later they subsided into the sea and then emerged again. Green dots show elevation of the reference line on the pillars above present sea level. Notice the scale. The variances in height have been about 14 meters. The elevation take into consideration a model for the general sea level change. Two versions of it are shown with the blue line and the green hatch line. Black dots show ground elevation measurements. Red arrows indicate times of pillar immersion according to radiometric dating of fossil marine organisms. Blue shading indicates time interval associated with subsidence, and uplift is shown in light brown, based on additional evidence. Prior to the most recent eruption in 1538, the columns emerged out of the sea, and the ground is inferred to have risen more than 10 meters. Following that, there has been subsidence again. Last century, the area has been rising, mostly in short episodes. A period of major unrest occurred in the 1970s and again in the 1980s, when there was more than 2 meters of uplift, as these leveling results show. Extensive seismicity occurred, and people were evacuated from the area of largest deformation. These time series of elevation change shown here is from optical leveling, a time series spanning 1 century with movement on the meter scale. Shown here is seismicity, earthquakes larger than or equal to magnitude 1 at Campi Flegrei from 1982 to 2016, in a map view and in cross-sections. Black stars represent individual events with size proportional to event magnitudes. The color indicates hypocenter density distribution with number of events per square kilometer superimposed on a digital elevation model. The cluster of seismic activity at shallow depth in the center of the caldera is very clear. This figure from Dauria and colleagues shows a very interesting compilation of geophysical and geochemical time series recorded from 1983 to 2010. Panel A shows a histogram of earthquake rate, with each spin spanning an interval of 6 months. Note that the vertical scale is logarithmic. The continuous black curve is an estimate of strain release. Red circles marks occurrence of long-period earthquakes. Panel B shows earthquake magnitudes. In Panel C, these circles represent the vertical ground displacement measured by optical leveling at benchmark close to the center of uplift. The staircase curve indicates the average vertical displacement rate between two consequent leveling surveys in millimeters per month. Panel D shows evolution of ratio of gases measured at the Boca Grande fumarole. The more carbon dioxide emitted from the fumarole, the higher the ratios. This figure from another paper by Dauria and colleagues shows recent GPS and INSAR results. Panel A shows shaded relief map of the Campi Flegrei area, with red dashed lines marking the approximate boundaries of the caldera. The star is the position of the Solfataro crater, while the cross is the location of the Mount Nuovo eruptive vent from 1538. The black circle is the position of the GPS station RITE, and Panel B shows the vertical component of this GPS station. Measurements are for the interval 2000 to 2014. The shaded area indicates the interval then shown in Panel C. That panel shows a comparison between the GPS displacement projected along the satellite line of sight as black line and an INSAR time series as red line. Panels D, E, and F show INSAR deformation maps in 3 selected intervals. Black circles indicate the position of GPS stations used in the geodetic imaging. In this period, inflation rates pick up again after a relatively quiet time period from 2000 to 2010. It is clear from the data presented here that the Campi Flegrei caldera is a restless caldera where large deformation occurs and up and down movements are larger than at many other volcanoes. The Naples metropolitan area extends into the caldera, therefore monitoring of the area of highest priority for INGV, the National Institute of Geophysics and Volcanology in Italy, that has a large monitoring network in the area.